So our next speaker will be Cedrick from DataStax. Cedrick, hi.
Hi, hello Mark. How are you doing?
Good, thanks. Good to have you here. You're going to be talking about open source projects with DataStax, in particular on
Yeah,
Cassandra.
that's correct. It's called Stargate, and it's a gateway you will put on top of your database, and all of a sudden you get multiple flavors of APIs.
Wonderful. Okay, the slide deck's working fine, so I'll jump off and leave you to it. Have a great presentation.
All right, thank you very much. Okay, so let's get rolling. I'm Cedrick Lunven, and I'm leading the developer advocacy team at DataStax. I'm kind of a Java geek, doing that for 10 years more plus. And I've had the chance to implement multiple APIs, GraphQL, REST, Grpc, and more. So I will just discuss these flavors and specification of API first, and then we will dig into this gateway and what it can do for you. Everything that will show you to that we show to you today is on GitHub. So this is the link. I will also share the same link in the chat, of course, for you to download. You will find the slides, the demo, and everything you need to start for free. So nothing to worry about. No need to take notes. Okay, so first, why would you need a data API? So why not exposing the database to your developers? Well, first, as a developer, you don't like to learn new languages. If it's a relational database, you will work with SQL. That's great. But if you work with, Mongo, Neo4j, Couchbase, whatever, each time you need to learn a new stuff. So it's not the best, right? So second, you do not really like to understand how the data is stored at the database side. How should you consider to put the data modeling? It's your job, but if there is somebody else doing that for you, why not? Also, running the database locally is not the greatest. If you could simply invoke something external, why not? And on the other side, the operators and database administrators are quite the same. They don't like you to access their database like that. The first stuff they tend to do is providing you some store procedure. I don't want you to request any table in any order that will hit my performance. Also, they don't like to open a wide range of ports. Sometimes it's needed for some databases. So in both cases, you need to introduce some loose coupling between people interacting with the data and the database itself. So you need that data services, data layer, data API. I don't know how you want to call that. So both sides are really interested in that. So APIs, of course, it's all that matter as of today. So multiple ways to implement an API. I think REST is everywhere, no doubt, for a decade already. So define your resources and get that. Here is just a screenshot of the tool I will present later. So for data API, REST is pretty good. I will show you that in a minute. So second idea would be to use Grpc. So Grpc is still working on the HTTP standard. Still, the payload is serialized protobuf. So the idea is to go as fast as possible. Why HTTP and HTTP/2? It's all about performance, using some multiplexing, keep alive, and do as much as you can on the HTTP wire. That's second flavor to do APIs. And last but not least, introduced in 2.12, but became very famous in 2.16 with GitHub announcing that now all the GitHub API will leverage on GraphQL. Also, Netflix is pretty active in that field. If you are a front-end developer, you are probably using already Apollo GraphQL for you. So why a new API standard? Well, the idea here is, again, to reuse the HTTP protocol, JSON, but introduce some strong type. So now you are working with entities type. Okay, that's great. But also you would like to retrieve exactly what you want. So you have a single endpoint exposing multiple functions and entities. By the way, requesting these endpoints, you get the schema, so you know exactly what are the functions available. This is the auto discoverability. That's great for GraphQL. So it's great. You don't need any documentation anymore. It's self-described. And when you invoke a function, you can exactly put what you need as a request, just exactly the field you need. So with that, so 3 candidates, REST, gRPC, and GraphQL. How do you choose? If you are an architect on a big company, you can ask budget to do a study, run a study for 3 months, and get a lot of criteria, cardinality, versioning, filter paging, and everything you can think about. Do the study, build the same API in the 3 languages, put some weight, do the matrix analytics, what is better each time. Notice that this slide is in French. That's so funny. And what you get is a simple decision tree, right? Simple, yeah, maybe not. And that's not even the good way to do. Okay, that's not how you should do it. If the architect does have a big decision tree, that would be just a nightmare to maintain because it's moving so fast. So instead of just the decision tree, this is my own feedback. I've implemented the same API in the 3 technology, and this is what I think about them. So REST is still king. Decoupling client server, okay? Great for API management and tooling like API management. I'm pretty sure that today and tomorrow we will get a lot of presentation regarding API management. Putting a proxy on top of an existing API just to introduce some great technical features like monitoring, throttling. But as far as I know, those APIs management system really, really work well with REST. But if you are using gRPC or GraphQL, then all of a sudden they could not really introspect the payload and doing all the same analytics per call, per resource that they tend to do. So if you want to use an API management, stay to REST up to now. It's coming, but it's still too early. But REST is not a silver bullet, and this is why GraphQL and gRPC came lately. So the payload is just too big, JSON, XML, boom. You can, of course, do serialized format on HTTP, but that's not the default. So no discoverability. If I give you a REST endpoint, by default, you don't know what you can do with that. If you don't have something like Open API specification or Swagger, you kind of stuck. And it's not really suitable for command line function like you would do with SOAP. Compute me something, do something. It's just here to provide CRUD, create, read, update, delete. So great for OLTP, public and web APIs, and limited business scope. You don't want to have dozens and dozens of resources. So REST, still a superstar, great for CRUD, so great for data APIs, right? So second, gRPC, all about high performance. I told you already about that. There you can leverage on multiple steps, synchronous, asynchronous, streaming. Again, do not stay blocked, go as fast as you can. But it's not great in a way that it's strongly compelled. If you don't have the proto file, you cannot generate a client, and you cannot use it. You need the interface. Also, protobuf is not the easiest when it comes to define the entities. You just field one after the other, side by side, no nested structures. So very simple data model, even if it's going as fast as possible. So that's great for everything internal. So distributed network of service, Google using that everywhere for microservice to microservice communication, but not really as a web API. Also, it can be great if you need to implement the same API in multiple languages. That happened to me before. So you had to implement the same is JavaScript, Java, and JavaScript, and Python. So use that. It was easy to have the same interface for the 3. Last but not least, GraphQL. What is neat? I told you discoverability, documentation, custom payload, still matching HTTP. Now, single endpoint. So versioning is not the easiest. I'm talking about not compatible backward, no backward compatibility. In REST, you like to have the major version number in the URL. You can't do that anymore. It's not great to handle the error, to do the error management, to be honest. If something goes wrong, you still get HTTP code 200 and just an ugly payload. Just it's 200, but it's an error. Also, if you want to execute request against a database, you may want to do some nested work with nested structure in your request. That's not great at all, because under the hood, it will do some joins at the database side, what we call the n+1 select. And if you are not, if you do not pay attention, that will consume a lot of resources. And so we need some time to do some rate limiting at the GraphQL layer as well. So this one is great for BFF, backend for frontend, expose exactly services for the React app or the Vue app, frontend only, and you just interact with your GraphQL background with exactly what you need. That's one side of the spectrum. Or a global API that multiple customers will use in multiple contexts. And as such, they would like to request the function in the way they like. This is what GitHub does. And this is why I think GraphQL will get bigger in the enterprise, because it could really be a nice interface and to serve multiple purposes, especially because now GraphQL Federation is coming, and GraphQL could be the layer when you do composition and aggregation. Okay, so that the three flavors of API and my own feedback about that. I find it could have some value for any one of you. Now, if I told you this gateway, this proxy on top of the database to introduce the loose coupling, provide you the three APIs and more, that could be pretty neat, right? Well, that's exactly the idea of this open source project called Stargate, stargate.io, working on top of Cassandra as of today. So Cassandra provides some enterprise and support for enterprise version, enterprise distribution, and a lot of tools to run Cassandra. So here, just a proxy to expose API, but also a lot of tools to run Cassandra in Kubernetes. So the Cassandra operator or Cassandra, it's really a culture about open source, and the more people will use Cassandra, the better for everyone, right? So here, the proxy called Stargate. Go to stargate.io, get the most of it. You can download it. You will find some easy to run Docker to have a first glance of what it looks like. Okay. It's a gateway, it's a proxy, so two layers. At the top, you find what we call the API extension, exposing REST, GraphQL, Grpc, the native Cassandra API, so CQL, Cassandra Query Language. No need to hide what was available before. And for Cassandra, multiple distribution, OSS 3, OSS 4, and anything that it's enterprise at DataStax. But never mind. Also in the middle, you may have noticed something called JSON document API, and that's really a nice business features. It's not easy to, Cassandra is a database working with tables, and it's not easy to work with documents in Cassandra. This layer introduce a neat way to interact with document, and I will show you in the 10 minutes how you can do that. Okay, so Cassandra is a NoSQL distributed database created 12 years ago. You can easily install Cassandra on a single node. You can have 3 terabytes of data, a few thousand transactions per second, but it is distributed. You really want Cassandra to be installed on multiple machines as a cluster. This architecture is peer-to-peer. There is no master. Data is distributed and replicated. You can group those nodes as what we call rings. Okay, so all data centers, but let's call it rings. So in Cassandra, you put some tables. Okay, so it's a column-oriented NoSQL database. So can be used for key value if you have simple tables, but not really by default to do some document-oriented. And if you store that database, that table in Cassandra, this is what it looks like. all the data are distributed across the cluster. So with that, you say, oh, wow, that's not really a good idea to do select star from my table, because you will get some pieces from each node, and it could be slow to do this full scans cluster. What you want to do is shape your queries in the way you always provide the column in red here. This is what we call the partition key. And as such, because all the data model with Cassandra is optimized for read, there are some strong constraints about the data model. And you, as a front-end developer, maybe just don't want to use Cassandra, it's hard to code, I just want to use some document. Well, this is what Stargate API could provide you as well. Cassandra could have, on a cluster, could have one ring, but multiple ring. You can read and write from everywhere. If I write my data on one node, I don't know, in Paris, it will be replicated by Cassandra itself on multiple regions. So now you have a single data layer available across multiple regions. It's not magic. The replication is done asynchronously. And what it's done for technical geographic distribution is also true for hybrid, or you can have a ring on each of the cloud, do some VPCP ring and open the port and the connection, and get that single data layer available across multiple clouds. Totally doable, especially using especially using now the Kubernetes federation features. That's are more and more there. Okay, so the use case for Cassandra, scalability. If you need more power, more capacity, simply add new nodes in your ring. That's the main advantage of Cassandra. Availability, data is replicated among your node, and data is also, there is no master in the architecture. So as such, you can lose any of the node. It's not a big deal. You still have a couple of replica of the same data. You're good to go. Distributed, get your data as close as possible to your users, or why not having some GDPR compliance, get your dedicated data need to be secure on one location, and like others that could be public, distributed across the world. No big deal. And cloud native, it's really focusing on Kubernetes and scale out instead of scale up. So add more nodes instead of putting some power on the existing database. So that database suits pretty well the cloud deployment. Okay, so before you implement your app as a developer and use the drivers to connect to an existing Cassandra ring, the driver will open some SQL connection to every single node, because the driver will do the health check monitoring and load balancing of all your requests. So that's one of the success of the driver. So cool. So now if I put you in front of that, the proxy, the data gateway, open source, you still have SQL. It's still available, but now you can interact with your data using REST, Grpc, and GraphQL, and it's stateless. The only thing you need is to provide an API key, and you will be able to interact with that. You do not want Stargate to be a single point of failure, so you would add multiple Stargate and have a nice load balancer in front of it, like this. And for the first time with Cassandra, there is a way to decoupling. Again, it's all about decoupling the data and the compute. Because if you need more compute, you simply add Stargate nodes in your proxy layer if you wish. And for the data, could only scale out your cluster if you need more capacity. To be honest, most of people scaling out the cluster are for capacity. So you tend to, that's fine. But if you eat some throughput performance, like doing some computation, OLAP, analytics queries, then you want to scale the compute layer. And you can now add some Stargate nodes. Okay, so a lot of talking. So at DataStax, we do have a service called AstraDB. It's Cassandra as a service in the cloud. And this service also provides Stargate ad hoc. There is a generous free tier there, so you can go there, subscribe, and have 30 million queries for free a month. So you can totally run small production there for free. After that, you get charged. I think it's a few cents per call, but you might think $35 of credit is about 30 million calls. No, this is the trade-off. And alongside for today, so I told you I will have for you some demo and something to follow step by step. So let me copy let me copy that in the chat for you. Okay, so that's the yeah. Put that in the chat. That's really there. Okay, put you the link now in the chat. Here you go. So you have everything you need to do the same demo as me. Demo, in 4 minutes, but still, this is what I can show you. Okay, the database is created for me on Astra, so I do have multiple databases. I do have one that I created called FreeDB. And if you go to connect, you can see you do have the document API, REST API, or use the driver or use the SDK if you want. So you do have a Swagger API, so to interact stateless with your database. So here I do have some, Swagger is all about executing API on the web. Client is generated for you, super easy. As you can see, you also have some documents, and with document, you can put some JSON document, retrieve some JSON document. Now you don't need a schema anymore. It's not strongly typed. Welcome document-oriented use cases. You do have some aggregation function. You can add, remove some list. And so with the single database, Cassandra, you can do some column-oriented workload and document workload. In a stateless manner, you now have the API. Sim, here you have some GraphQL. So I open this GraphQL going there, GraphQL API, and opening the playground. Stargate not only export the API, but also provide you the tool to use the API. So Swagger, Playground, Grpc client, it's all there for you. Okay. To get that working on your machine, just follow the step on the README. Okay, I have nothing to sell to you. It's free, and Stargate is open source, so go for it. Okay, 2 last minutes. So Stargate is very rich. I have a lot of features. So the REST, document, GraphQL, SQL, Grpc APIs inside. I have a lot of stuff you can do. It can be a bit overwhelming. And if you have seen the Swagger page with dozens and dozens of resources. And this is the reason why my team also created some SDK, so clients wrapping those API for you to work super easily with this API. Just a couple of screenshots I've done for you. So if you want to Stargate, just provide the parameter with the builder at the beginning, provide the user the endpoint of authentication REST GraphQL. So you will authenticate with the Cassandra credential, get back a token, and then could invoke every single endpoint REST GraphQL Grpc using that endpoint. SQL local still the same. Okay. Here is how to find a document and subdocument is working super easily. And you know what? That's it for my presentation. If you like this kind of content and would like to manipulate those, we do have a YouTube channel, DataStax Developer, where we are doing lives twice a week. So 2 people live, guiding through you through some step-by-step instruction, like the one I shared with you before. And we are building stuff together. So we will have one in a couple of hours now. It's 6 p.m. Paris time in 2 hours. But again, feel free to have a look and join us to one of the live and see if you enjoyed as well. And with that, last slide is really to thank you. You have my coordinate for any question or more stuff about that. Do not hesitate to reach out to me. Thank you very much.
Fantastic. Thanks so much, Cedric, and right on the dot. That was great, and I love the element of the interactivity in there as well, and the opportunity for our participants to sort of join you in testing all of that out in that GitHub repo. So that the link's still live for that on the in the chat. So if you wanted to, you could also, and you didn't get to write down Cedric's details, then you can contact him via that. Okay, thanks so much. I'll invite you to leave the stage.